Topic 12. Phases of matter. Part 6. Pressure in a fluid. A fluid can be a liquid or gas. Pressure in a fluid. Consider a column of fluid like this in cylindrical shape. The pressure at the bottom here is due to the weight of the fluid above it pushing down on this area A. Now we come to derivation of formula of the pressure in the fluid. I've already read all this on the previous slide. Once again, here's a column of fluid of density ρ and base area A, and the height is h. Formula of pressure, you all know that. P is equal to force over area. Weight due to mass m of the fluid and the gravitational field G is given by this W equal to mg, mass times gravity. And then you substitute this equation 2 into equation 1 to make a new formula for pressure. Try that yourself. Don't forget, weight is a force of gravity. We can relate the mass of the fluid to the density and volume of the fluid by this formula that you're all familiar with. Mass is equal to density times volume. And we substitute this equation 3 into equation 2 on the previous slide. You get equation 4. Do that yourself. But also, volume of the column of fluid can be expressed as base area times height. That gives you volume. And you substitute this into equation 4 here, and it'll give this new equation. That's for you to work out. The next step is cancel the common factor A, the base area. And bingo, you've got it. P equal to ρ g h. For help, see the dictionary. Don't forget, you have to memorize this whole derivation process. You now have a formula for fluid pressure that is independent of area or base area. It only depends on the height of the fluid. Don't forget, always show the diagram when deriving this formula. The diagram is that column of fluid like this, with the base area down here A. Now we look at upthrust. Upthrust is the buoyancy force of a fluid, either a liquid or a gas. For example, in water, it is the upthrust that keeps something afloat. What causes an upthrust in a fluid? Why do some objects float and other objects sink? We will endeavor to answer them in the next couple of slides. Imagine a column of fluid like this, and inside this column there is a cylinder of plastic here. Since pressure increases with depth, the pressure at the bottom is greater than at the top. Pressure increases with depth because the formula says P equal to ρ g h. H is the depth. Next, pressure is proportional to force because P is equal to F, or force over A, or area. So there is a greater force pushing on the bottom of the cylinder than on the top. So this pressure here pushing up is bigger than the pressure here pushing down. And so there's a resultant force, or the difference in force. And this resultant force is called the upthrust. See the dictionary for definition. Here we have a diagram of an object in water. It says here, an object in water has two forces acting on it. Firstly, its own weight, the force of gravity, acting down on it, and then secondly, the upthrust by the liquid, in this case water, acting up on it. Upthrust can also be called buoyancy force. Now number 2, if the upthrust force is bigger than the weight force, the object will float because the resultant force is up. If the upthrust is smaller than the weight, the object will sink because the resultant force is downwards. Now, what if the two forces are equal to each other? You can find out the answer yourself. Some pictures you may like. They are all to do with pressure. Some more pictures of interest to you. See whether you can figure out what each one of these is trying to illustrate. For example, this one here shows that the deeper you go into the water, the greater is the water pressure.